Yeah, welcome, grade 12's physical sciences, teachers, learners. This is the platform where we share the knowledge and expertise in the subject. We are continuing to solve problems in the way, trying to enlighten some of the concepts in the sections that we are dealing with. The section for now, it's electrostatics, which deals with charges at rest. We're taking a question from the recent question papers. It's on electrostatics. We are dealing with the problem solving. So the question itself says, a sphere N with a charge of minus 30 microcoulomb is placed on an insulated stand. Sphere M with a charge of minus 20 microcoulomb hangs on an inextensible string from a horizontal beam, and it's a distance of 80 centimeters. Immediately when you see 80 centimeters, know that 80 centimeters, the 80 centimeters must be converted immediately to meters, which will be 0.8 meters. Just shift the comma 3 times or divide by 100. Now moving forward, they say it's 80 centimeters from sphere N, as shown in the diagram below. You can see from the diagram we are given the compass there, direction, just to see, to show that north is up, west is on the left, and east is on the right. The first question they say to us, which is 7.1, they say state Coulomb's law in weights. Because this first part will be dealing with Coulomb's law, so we are stating the law. Before we can state the law, the strategy is that go to the formula sheet and see this formula. F equals to KQ1 Q2 over R squared. That's where the definition is coming from. Therefore, the definition will go by saying this F is an electrostatic force. Normally, they say the magnitude of an electrostatic force between 2 point charges, is directly proportional to the product of, the word product very important, product of the charges, thus we have F is directly proportional to Q1 Q2. That's the first part of the definition, and the second part will say F now is inversely proportional. Now second part, directly proportional to the product of the charges and inversely proportional to the square of distance between them. Square of distance between the charges. Very important that inversely proportional to the square of distance between the charges and directly proportional to the product of the charges. You get 2 marks for saying that. 7.2, now they are saying to us, look at the question. They say from this diagram that is given here, draw a labeled free body diagram for sphere M. You are showing all forces acting on sphere M. Will be guided by the marks here. Normally 3 marks mean that we are expected to draw 3 forces on M. Remember, all free body diagram Very simple. They will all have the weight, which is the force that the earth exerts on this. It can be Fg or just small w. Then from the dot which is given is there's a tension in the string, and then the last force will be the force experienced by the repulsion of this, because the two charges are negative. Therefore this will be the force of N on M, or just say Mn is fine. Also, this is the 3-mark question, so you will get 3 marks. But bear in mind that once you draw this one, obviously they are going to ask you to use the triangle of these forces to say when the tension, and then when the weight, and this will be the force. So you will be requested to use this triangle, obviously, if this is the case. Now, once we can find two forces here, of which we can, the weight, we need to be given the mass. This we can use the Coulomb's law between the two charges. So let's go to the 7.3 and see. 7.3, of course, it has got two sub-questions. We have got 7.3.1. It says to us here, calculate the magnitude of the electrostatic force between two charges. Remember, as we define Coulomb's law, we are going to use the Coulomb's equation. You copy as it appears in the formula sheet. F equals to KQ1 Q2 over R squared. Then K is a constant value. It's 9 by 10 to exponent 9 multiplied by the charge on M is 30 by 10 to exponent minus 6 is 30 microcoulomb, and the one on M is 20 by 10 to exponent minus 6, all divided by the R will be 0.8 squared. Then if you use your calculator, in this case, you will find that the force is 8.44 newtons. If you approximate the second decimal, you can also accept those who will just write it as it is, 8.4375 newtons. So that will be the answer now. For 4 marks, for 3 marks in this case, 1 mark for the formula, 1 mark for substitution, 1 mark for the answer. So this will be the 3 marks that will be allocated. We go to 7.3.2, which is the last question in this one. Then they say to us, calculate the magnitude of the tension in the string if the mass of the sphere M is 90. Remember, once they give us 90 grams, we don't work with grams in paper 1. We work with kilograms. Therefore, this will be now 0.09 kilogram. So we'll be working with this one, or you can just say it's 9 by 10 to exponent minus 2 kilogram. Fine, or 90 by 10 to exponent minus 3. Now we're calculating the tension. So with this mass they are giving us, remember, as I said, you need to draw this so that you find the weight. We have already found the force, then we need the weight for us to calculate the tension. So then this is the diagram. We draw it vectorially. You can start with the weight and then followed by force and M, just calculate it, and the last one will be the tension. That closes the figure. This is a right angle triangle. So if you can know the weight, we can use Pythagoras to use that one. Let's find what will be the weight. Weight equals to mg. We know that one. Mass is 0.09 multiplied by 9.8. Therefore, the answer in this case, you get 0.882 newtons. That is the weight. Then from here, we can use Pythagoras to find the answer now of the tension. If we know this force and this force, then we can know the hypotenuse using Pythagoras. Therefore, T squared will be the same as now. In this case, the weight squared plus F and M squared. Therefore, this will be 0.882 squared plus this one we calculated is 8.44 squared. Therefore, the tension will be 8.49 newtons. This is 4 marks. Being 4 marks, then you need to be given 2 marks in this one, and then 2 marks also here. Then you must get 4 out of 4. Fine, because we cannot award a formula that is mathematical in physical sciences. This is a Pythagoras theorem, so it's no mark for it in physical sciences. That is a total of 12 marks. So I hope at least it's clearer now. Our next stop will be electric field. Thanks for now.